Hello everyone. In this video, we are going to discuss about lacing part 1. So first I will show you the diagram. Okay, later we'll discuss about each and every provision and the concepts in the lacing system. So I'm going to take the two channels here. Mostly we use channels and I section and angles as a column. Okay, of course in some cases we may use circular sections also, but usually prefer two channels, I section or angles, four angles. Okay, but usually prefer channels. So first I'm going to show you the cross section of the built-up column. Of course, previous class I have shown the same diagram, so I'm going to repeat it again. So this is one channel. This is one more channel. So here we have to connect these two channels. So now we are going to connect these two channels by using a member called as flats. By using flats, we are going to connect these two channels for increasing the area and for increasing the minimum radius of gyration. So this is the bolts. So now this is the cross section of built up column or whole column. So when we can see the cross section, either on the top view or from the bottom. So if you observe from the top or bottom, so if I look like this, then I get the cross section of this floor or room. Agree or not? So for column also, so if you see from the top or bottom, you can see the cross section. Agree or not? So this is the cross sectional view of a column. Now I'm going to show you the front view. So in this diagram, so in this cross section, length is perpendicular to the board. Do you agree or not? So in this cross section, length of this column is perpendicular to the board. So if I see from the side view, then I can see the longitudinal view or not. So that longitudinal view we can observe on the flanges. Agree? So now I am going to show you the longitudinal view. Okay. So this is one flange. Okay, this flange, and this is another flange. So this is the height of the column. Clear? So this is one flange and this is another flange. So this is the width of the flange. BF. And this is also width of the flange BF. So if we want to show that as same in this diagram, so this is width of the flange. And here also this is width of the flange BF. Okay, BF, width of the flange. And here this is the spacing between those two channels or two components X. So in this diagram, this is X. Agree or not? So now in this plane we have provided the lacing system or members of the lacing. Agree or not? So if you see in the cross section, the members of the lacing seems like this. Agree or not? But if you see in the cross section, the pattern and everything can be seen clearly. Okay. Now for a lacing system, at the top and bottom or at the ends, we are going to provide end patterns like this. So that is mandatory. So we have to provide the end patterns for a lacing system. So we are going to provide a bolts here or welding, whatever it may be, bolts or weld. So these are called as end patterns. Okay, they are called as end patterns. End patterns. They are called as end patterns. They are called as end patterns. So now after providing the end patterns at top and bottom, so the name itself end patterns, so they are going to provide at ends. So now after providing this, we are going to provide our lacing members. So we are going to provide the lacing members inclinedly like this. So this is one lacing member. This is how the lacing members is going to provide it. And we are going to connect them by using bolts or weld. It depends. Agree? Clear? So this is the lacing system. Okay? So now if you observe, this is the longitudinal axis. Agree? This is the longitudinal axis of the column, individual component. So now here we know that we are going to provide lacing system whenever that column is loaded by eccentric load. It means the load here is the load in the column here is like this. So here I will show P. Okay. So the load P and this is the spacing X. Clear? Now if I want to show some dimensions here, this lacing member is going to make an angle with the longitudinal axis theta. And if this is the spacing between the lacing, so this is the spacing between the lacing, is going to represent it with C. Okay, so if it is C, then obviously it is also C. And this is also C. And this is also C. So this is the spacing between the lacing members. And then if you observe for this formation, so this is the length of the lacing member L. Okay, so this is the diagram. So first you take this diagram clearly and later I'll explain each and every concept and every provision. So first you take down this diagram. So this is the longitudinal view of the lacing member. It means this is one flange and this is one flange. So this is flange, this is flange. At that plane we are going to provide lacing member. So if you observe, here we are having two planes of lacing. Yes or no? So here we are having two planes of lacing. This is one plane and this is one plane. So whenever we are observing the longitudinal view, then we can observe only one plane of lacing. Yes or no? So in this plane, so if in this view we can observe the lacing on this plane. So that there exists a lacing on opposite plane. Okay, there exists a lacing on opposite plane which we cannot see in this view. Okay, in this longitudinal view, we can observe lacing on only one plane. There exists a lacing on other plane which cannot be seen in this view. That is longitudinal view or in length view. But in this cross section we can observe both the planes. But there we cannot observe pattern and number of lacing members. So take this diagram first. Okay. So now let's start the discussing the concepts of it. So we know that when we provide the lacing system, if the column is subjected to eccentric point load or eccentric axial load or compressive load, then we go for lacing system. That is the point next. So write a point wise. Generally flats, bars, angles, tubular sections, etc. are used as lacing member. But we prefer flat. So it means, so this is a lacing member or not? So this is one lacing member. So by using this lacing member, we have connected these two columns or these two channels. Agree or not? So for that lacing member, we may use flats, bars, angles, tubular sections, etc. Okay, channels and angles, small angles like angles we can use, but we prefer flats. But we prefer flats. That is the point. Next, lacing along the length. Lacing along the length should not vary. Should not vary. It means, see here, the spacing between this lacing member and this lacing member is C. And again here also this lacing member and this lacing member is C. So it should not vary. So it should be same. Here also C and C. And that if we see the inclination of this lacing member with the vertical axis or longitudinal axis theta. So the same. The inclination of this member will also theta. And again this member is also theta. Again this member also should be theta. So it should not vary. Okay, that is the meaning of it. So the lacing along or lacing system, or you can say the lacing along the length should not vary. It means for the symmetry. Okay, for the symmetry, it should not vary. That is the meaning. Okay, and that is the provision we should follow. So then only the easy analysis is possible. If it is varying, then the analysis is very, very complicated. So based on that, the lacing should not be varying. And one more thing, third point, lacing on one plane should be mirror image to other plane. So usually we are going to provide lacing on two planes. This is one plane of lacing and this is another plane of lacing. But in this view we cannot see both the planes. Agree or not? So in this plane, how we have provided the lacing? Exactly or similarly we have to provide the lacing on other plane also. So the main idea of these two is for the symmetric connection, so that for symmetric system, so that analysis is very simple, or else it is very, very complicated. So for that we should follow these two. So first is lacing along length should not vary. It means that spacing between one lacing member and one lacing member should not vary, and the inclination of lacing member should not vary. And then how we have provided lacing on one plane, exactly we should provide the lacing on other plane. So these are the things. Okay, these are the things. So first we take down these points. So next, now let us deal with the provisions. Okay, these are some concepts. Of course, we are having some more concepts, and along with that, we deal with the provisions given in the IS code. So I'm going to rub this. So first provision, effective length of the lacing column. Effective length of the lacing column should be increased by 5%. What is the meaning of it? So with an example, I'll explain an example. If both ends are fixed. So if both ends are fixed, what is L effective? KLR L effective, how much it is? 0.65 L. Agree or not? So this is the effective length of a column if both ends are fixed. For example, if that column is built up column and we have made that built up column by using lacing, then effective length is, so in that case L effective should be increased by 5%. It means we should multiply, we should increase it with 5%. So if we increase 5%, then we should multiply with 1.05 into 0.65L. So it comes out to be 0.68 something L. So that is the meaning of it. So the effective length of the lacing column should be increased by 5%. So take it down. So this is the provision. So very, very important provision. So that is the meaning of it. So if it is, so if you provide only single channel as a column, then simply the effective length when both ends are fixed is 0.65. But we have provided the two channels and we have connected the two channels by using lacing system. Then effective length when both ends are fixed should not be taken as 0.65. It should be taken as 1.05 into 0.65 L. That means that comes out to be approximately 0.68 L or something. So that is the provision. Okay.